Hello everyone, good afternoon. Welcome to the class ECE317 DSP I. Today we will keep working on the topic about how to apply Z-transform to solve system. Last time we have an example. I didn't finish it, so we start from that. Alright. Okay. ECE317. This is for the 8th week Wednesday's class. The problem last time, let me see. I have that. Okay, so this is the problem we did last time. We have a system. This is the equation, the system satisfied, and we want to find the impulse response in 3 different cases. The first case, we suppose system causal. Second case, we suppose the system is stable. And the third one, we suppose the system is anti-causal. Then how to solve it? We use Z-transform. We can have the transfer function actually directly obtain. You can directly obtain the transfer function from the system equation. This is 1, 2.5, 1, right? We have these 3 coefficients. So here's 1, 2.5, and 1. And after these coefficients, the first y, nothing changed. So it is just 1. Second one, we have delay by 1. So here's a z to negative 1. So the z to negative 1 seems like a delay. And here is m minus 2, delay by 2. So here's a z to negative 2. And then we use partial fraction. We write h of z in this way. It's a summation of 2 terms, and we already have a. A is here, 4/3, and the b is here. Is negative 1/3. Okay, then we can have the result. Then we can have the result depending on our c, depending on the cases. Case 1, causal. Then we know the RC should be like this. RC will be z larger than, I have 2 numbers, 2 and 0.5, so it should be larger than 2, larger than the larger one, right? These 2 poles, I have 2 poles, 2 and 0.5, so I wanted it larger than the larger one, so I have this one. By this RC, then we can have h of n equal to this is a 4/3, so let me see, this is a 1 plus 2. Okay, so this is a 4/3 plus 2. Here should be minus 2. Can you see the bolts? Is here. I have h of z. Okay. Alright. A is a 4/3, and here's a plus 2. Actually, this is 1 minus negative 2. So here's a negative 2 to the n, u of n, and plus b is 1/3, negative 1/3, and here's a negative, right? 1 minus negative half, so it's a negative half to the n, u of n. Okay, so we have h of n. The graph will looks like some value like this, and for negative n's, you check the u of n, right? You have u of n. So when n is negative, the value of h should be 0. Okay. This is the first case. Second case, stable case. Stable case, RC contain the unit circle. Contain the unit circle. And that's must. If it is stable, then RC must contain the unit circle. So now you see the poles. We have negative 0.5 and negative 2. So which part contain the unit circle. Unit circle actually is 1. So we have to have these will be z smaller than 2, larger than 0.5, right? So this interval contain 1. Unit circle means absolute value of z is 1. Yeah, RC is this one. Then we can have h of n. The A, I still use the A is 4/3. A is 4/3. Then times this one, I need a -2 to the n. Okay, so here you can put the u of n or u of -n minus 1, depending on RC. You compare, here's a 2, right? This is 2. This is 2. Absolute value of -2 is 2. And the RC is z smaller than this 2. Smaller than this 2, so here will be u of -n minus 1. Right? If it's larger than 2, here's just u of n. And furthermore, you need a negative in the front. Okay, so this is the first term. First term related with this a over 1 plus 2z to -1. And second term is b. B coefficient is -1/3. B is -1/3. Yeah. -1/3. And the pole is -0.5 square. Okay, then here what where we have u of n or u of -n minus 1. Which one? You check here. This is a z larger than 0.5. Now in RC is larger than 0.5. So here is just n. Okay, that's the answer. If you give the graph, it will looks like when n is 0, so this is when it's 0, this is 0, and 0, so this is 1, -1/3. It's here. Right? It's here, -1/3. And then square, sorry, I put 2 here. Is n. When n is 0, this is -1/3. When n is 1, this is a -half, -1/6. So it's a positive, -1/3, so positive 1/6. So the value should be then negative, then positive, then -1, then positive, things like this. Right. And when n is negative, this term tends to be 0. We only have these. When n is -1, I have a positive value, right? -1. This is half. 4/3 and half, so 2/3. This is 2/3, something like this. 2/3. And then there will be this one, then this one, then this one, like this. Alright. Yeah. So the value will be inside the range like this, right? Yeah. So this is a h of n in the stable case. And the case 3, the system is anticausal, right? Anticausal. Anticausal, the RC will be z smaller than some value. Smaller than, you have 2 poles, right? -2 and -half. You take absolute value, you have 2 and half. Smaller than them, so it should be smaller than 0.5, right? Okay, and h of n, now both sides I need a u of -n. That both terms I need a u of -n minus 1. So this is -4/3, -2 to the n, u of -n minus 1. Right, because z is smaller than 2, of course, smaller than half, right? Then plus 1/3. The coefficient is -1/3, but you have actual negative in the signal itself, so here's a plus 5 to the n and the u of -n minus 1. Okay, and this case you can see the graph will be for positive n's. This should be 0. Even n is 0, they are 0. And for those negative n's, there will be signal here, like n is -1, and the -1, here's a positive value. -1, this is a -1. -1, so this is a 1/2. This is a, so 2/3, and 2 minus is a plus 2/3. And this is when n is -1. This is a 2, or another 2/3, -2/3, which is 0. It's still 0. And next will be is positive, then negative. Should be negative some value, some things like that. Negative something like that, or positive, larger and larger, because this one for negative n, this is a like a -1 is -2, and -2 will be +4, right? Larger and larger, and larger and larger. Yeah, things like that. Okay, so we have the answer. All right, now can you remember how to solve this problem? Use Fourier transform. Okay, to solve the same problem by Fourier transform, we need to work like this. Step 1, find a particular solution. Remember? Yeah, you just use Fourier transform. You can find the particular solution. Actually, this particular solution, according to the stable case, should be this one. It must be yp. Actually, this y is h, right? Y is h, because input is we use input is dirt, but is output, right? Yp will be this one, will be just this one. I copy it here. Negative n minus 1, minus 1/3, -0.5 to the n, u of n. Yeah, it must be this one. And second one, find the homogeneous solution. And here we know they have 2 poles, right? They have 2 poles, -2 and -1/2. So that will be alpha1 times -2 to the n plus alpha2 times -0.5 to the n for any alpha1, alpha2. And step 3, by initial condition, to determine alpha1, alpha2, then this h of n should be yp plus yh. In yh, alpha1, alpha2 now are given values, right? Then you can have the impulse response. And the initial condition, we have 3 cases. For first case, the initial condition is causal, right? Causal. So we have for negative values, for negative n's, they should be 0, right? And the third case, the anti-causal, there will be y1 equal to y2 equal to 0. And the second case, it is a causal. It's stable. Stable, that means alpha, not alpha, YR. Actually, YR is also YP plus YH, right? It's also YP plus YH, but alpha1, alpha2 are any, right? Are any. For stable, you want this one is bounded. So you plug in, you put the YP, YH, you plug in, do some simplify, and then you will see, like if you have this one, the n cannot be, if n go to positive, this one will give you 0, right? So if you cannot cancel this alpha 1, then alpha 1 must be 0. Yeah, alpha 1 may be cancelled with some coefficient here. If you can't cancel, then you have to let alpha 1 equal to 0, right? We have example before, right? So if you do not have Z transform, you can solve same problem, but you need more steps, more complex, right? Here you just you do partial fraction. Yeah, here you just you start from h of z, then partial fraction. Okay, now you get it, right? You can write the answer directly, depending on what is your requirement. It's a stable or causal or something else. Yeah. Okay, so this is the first example. Now let's consider another example. For this example, we will apply this rule. We have y of z equal to h of z times x of z, right? We have this one, and then our c, there will be our c of y equal to the intersection. We use RH intersection with Rx. So we have this one. All right. We apply these two. The question like this. Question. We consider signal. Let me see. Okay. Consider signal x of n is 2 of 1/2 to the n u of n plus 6 of 3 over 2 of n u of negative n minus 1, 6. Okay, and y of n is 3 of 1/2 to the n u of n minus 2 of 1/2 one third to the n u of n. Now we consider, suppose we have two signals. Now the thing like that, xn is the input of an LTI system, and y of n is the result, output. What do we want? We want to find the following: h of z, and it's RC. All right. Secondly, then this one won't be difficult, right? Suppose you already have h, you can find h of n. And then similar, we can have another thing is also, you can have it directly from h of z, that is a equation of the system. And fourth, you want to check the system. The property of the system is the system stable, causal, or anti-causal. Alright. Okay, now how to do it? Now we use actually we can have similar problem for Fourier transform. In that case, you need to find the frequency response. But frequency response, just frequency response. You do not need to consider RC, right? Yeah. But now we need to consider what is RC. So we start like this. the first one. What is x of z firstly, right? X of z. We have x. What is x of z? It will be 2 times 1 over 1 minus half z to negative 1, and plus 6 1 over 1 minus 3 over 2 z to negative 1. Okay, this is a u of negative n minus 1. So here is I need a negative here. And our c, the first one I want z larger than 1/2, and the second one I want z smaller than 3/2. So our x, the RC of x, will be all of the z. The z is between half and 3/2, right? I use 0.5, smaller than z, smaller than 1.5. Alright, yeah, this looks make more sense, right? Okay, this is the x. Then second we check y. Y will be 3 times 1 minus half z to negative 1, and minus half 1 over 1/3 z to negative 1. And our c, the first one is a z larger than 1/2. Second is z larger than 1/3, right? Yeah, you check here, 1/2, 1/3. And then our y will be the common area of these two, so there'll be z larger than 1/2, right? Yeah, if you want, you can have a graph. The RC here, the first one is outside, and the second one is inside, right? Second one inside. Here's 1.5, here's a 0.5. The common area of these two, there will be a ring, right? There will be a ring. Here's a 0.5, here's a 1.5, right? So you get it. And this one, the first one is outside, and second one is also outside. So the common area is just the larger one. The smaller one is 1/3. The larger one is the radius is 1/2. So the common area is this one. All right. Then we want to find h of z. So h of z will be y of z over x of z. Okay, we need to do some calculation. Y of z, let me merge these two fractions together. So it will be denominator is 1 minus 1/2 z to negative 1 times 1 minus 1/3 z to negative 1, and the numerator will be 3 of 1 minus 1/3 z to negative 1 minus 2 of 1 minus 1/2 z to negative 1. So this is y. And x is just these two, right? I merge these two together. So this is a denominator is 1 minus 1/2 z to negative 1 times 1 minus 3/2 z to negative 1. And the denominator is this. Numerator will be 2 times the second term is 1 minus 3 over 2 z to negative 1, and plus 6 times 1 minus 1/2 z to negative 1. Alright, okay, it's a large fraction. Numerator, okay, both contain these, right? I typed there, yeah. So these two can be cancelled, right? These two can be cancelled. So in the numerator, we have, okay, this numerator is 3 minus 2, the constant is 1. And the z inverse, this is negative z inverse, this is positive z inverse, okay, no z inverse. So this is just 1. 1 over 1 minus 1/3 z to negative 1 is the numerator. And denominator, here's 2 plus 6, I got 8. Let me see. I want to cancel something. Oh, I change it. Can I change? What's my example? Second, x is this, y is this. So for x, this is a plus 6. Oh, I can't cancel it. I want to make it simple so I can cancel it. Cancel one of them. Oh, yes, this is a negative 1. I'm sorry. This is a negative 1 here. I forgot this. So here, this is a negative 1. Negative 6. Here, when I give problem, I started being cancelled. This is 6. Okay, so it's not 8, not too large. It's 2 minus 6. 2 minus 6, there will be negative 4. Negative 4. And then this is a negative 3 of the inverse. And here is a positive 3 of the inverse. So the z inverse term cancel. Numerator is just negative 4. And denominator, this one, the same cancel. So I have 1 minus 3 over 2 z to negative 1. Okay, so this gives us what? This is a negative 1/4, right? Negative 1/4. And this one should be in the denominator. And this one will be in the numerator. Okay, this is h of z. This is h of z. But what is RC of h? You check it here. RC of h of z, possible choice. Possible choice. You see here, you have a 1/3 is the pole of h of z, right? So you will have 1/3. Then you have two choices, here or here. RC will be z larger than 1/3 or smaller than 1/3. Yeah, you check the pole. Check the pole. So the RC will be either this one or that one. One of it. Which one will work? You need to compare. We know the RC of x and y, right? We know Rx is what? Oh, which way? Rx is here. Rx is here. I give a, so it's this one. 0.5, 1.5 is here. This is Rx, right? And Ry is larger than 1/2. Larger than 1/2. Or Ry is here. It's still here. 0.5. This is Ry. And now RH will be 1/3. 1/3 is here. And it will be here or here. Okay, we have two choices. And we also know, right? We know these three factors, and we also know our H intersection with Rx or equal to Ry. Ry is obtained by the intersection, right? Intersection of H and X. Actually, we know Y equal to H times X. So we have this one. Then you see which one will work. Our H is here. You need an intersection of these two, and which will be this. Okay, so you have to use this one. This will be RC. Not exact same. The Ry may be larger than that, so you are like this. All right. Yeah. So So we can have our edge will be z larger than 1/3. You cannot use smaller. Smaller than the Rx and Rh, no common area, right? No common area. No common area. So we have this. Alright, now we have 10 RC and H of Z, and it's RC. Okay, this is the first question. First question. I have 3 questions. I have 3 or 4 questions. Questions here. I have 4 questions. 1, 2, 3, 4. So first one is we get the answer. Right? We get the answer. And right here, H of Z equal to -1/4 is 1 minus 1/3 Z to -1 and 1 minus 3 half. Right? H of Z. That's 3 half. 3 half of Z to -1. Okay. This is the H of Z. H of Z. Actually, for this kind of things, we also call this 3/2 as a 0 of H of Z. And this is the pole. This is 0. 0 of H. And 1/3 is a pole of H. Alright, this is the first question. Second, we want to find H of N. Then we can write it directly. We know RC is in larger side, so we use U of N. U of N. So this is a coefficient is -1/4. Here's 1 over it, 1 over it, 1 over this, 1 minus 1/3. So this is 1/3 to N and U of N, right? U of N, because RC is larger than 1/3. And then minus 3/2 times Z to -1. This gives us a delay. So this will be same 1/3 to the N, but delayed by 1. And U of N delayed by 1. Okay, that's it. This is H. This is H. And the third one, we want to find the equation. You know H, right? You know H here. So equation should be, I put this inside. H of Z. Let me rewrite it. It is 1 minus 3/2 Z to -1. Here's a -4 plus 4/3 Z to -1. So we have the equation -4 times Y of N plus 4/3 times Y of N with a shift by 1 and equal to X of N minus 3/2 X of N shifted by 1. Okay, so this is the equation. This is the equation. And the fourth question, stable? Stable? Okay, you can check H. You can check H. The element, the value of of H for different N, if they go to 0, if they won't go to infinite, then it is stable. Then you check if N in the negative side, then both will be 0, right? If N is -1, -2, both should be 0. And when N go to positive side, N go to positive, go to large N. This is, you see, 1/3 for large N. The power is N. This will tend to be 0. And this is similar. 1/3, the power go to large, so this value tend to be smaller, tend to be 0. All right, so we can have yes, and causal. You are checking for negative N's whether they are 0. Yes, they are 0, right? For negative N, because this U of N and U of negative N minus 1. So we know there is causal, right? Causal, yes. Or say H of N equal to 0 for N is smaller than 0. And this one, summation of H of N, absolute value, is finite. Finite. Yeah, if you do the summation, right? If you do the summation, they're finite. And anti-causal, of course no, because it's causal. These two cannot happen at the same time. It is causal, then cannot be anti-causal, right? Anti-causal, right? Okay. All right. So this is this example, right? This is example, and let me see. If we want to do the similar thing, use Fourier transform. Where's the problem? Let's see. If you want to do the similar thing in the Fourier transform, almost the same. But the only thing, we have two things. The first thing is for this part. For this part, can you find the Fourier transform? So when x and y are given, can you find the Fourier transform of these two signals? In some case, you cannot have Fourier transform. To find the Fourier transform, you need some requirement. So the same method can be applied. Use Fourier transform. Same problem can be solved by Fourier transform, but you need more requirement, more restriction. The signal, you have to make sure the signal they have Fourier transform. All right, this is the first thing. Second thing, you cannot have the RC discussion. So when you calculate, that is determined by the first requirement. Just if they have the Fourier transform. In this example, you can use Fourier transform. Both you can find Fourier transform. But for some other problems, maybe you cannot have Fourier transform. All right. Okay. Oh, today this one is shorter, but that's all for today. This is what I want to give to you. Then next time, this is for Wednesday class, right? The next time and Friday's class, I will give you a review. Then next Monday, we will have the midterm exam. All right. Okay, then see you next time. Okay, bye bye.